Yeah, so as I stated in my last video, or a couple of videos ago, I'll start doing these devlogs kind of things for my final school project. That's the Danish title, but in translated it's called the Environment Saver. And for now it's just a small demo where you have to walk around a beach collecting trash. And you can see I have these few small functions like I can teleport around. I've built this using ProBuilder, a trash picker. It's pretty basic, but works for now. And I can use this trash picker to like pick up trash. And if I throw it, I have these different containers. I can throw this in the organic trash. Get the buzzer sound, because of course a can is not going into the organic trash. But yeah, if I throw it in just for now, you can see like the beach is empty. But if I throw it in the can container, well, I throw this in the correct container. See, the trees are growing, animals are spawning, not the typical beach animal, the chickens, but oh well, for now it works. This might seem a bit basic, probably is for some, and for others not so basic. But this is not a simple, if I put trash in this container, then this happens, like an if statement. This is actually done using design patterns. So I use the state pattern, keeping tracks of how much trash have I collected. And the script I use to observe the environment state is actually also a singleton, so I use that design pattern as well. And then I use the observer patterns from the animals over there and the trees and two different scripts to observe what happens and what state is the environment currently in and how should we react corresponding to the current state of the environment. Yeah, so now I'll just jump back into Visual Studio and I'll show you the code, walk you through it. So yeah, I wanted to walk you through the scripts. Let's start with the environment progress. Here I use a singleton pattern. For those who don't know what that is, that means that there's only ever one instance of this class in the scene. This makes it super easy for other scripts to access the environment state without manually linking references. So I make it a singleton by using this public static environment progress instance. I use a get, so the other scripts can access it, but I use a private set, so no other script can change values in this. In the awake method, I set the instance to this. For the state pattern, I've created this enum. For those who don't know what an enum is, basically think of it as a list of options for a certain category. So if you had this private enum called weekdays, then you would have Monday, Tuesday, Wednesday, so on. Yeah, so this is the state of the environment. We have heavily polluted, which is the starting state, the current state. I've set this in the editor. We have polluted and slightly polluted and then clean. So this is just where I add collected trash to the total amount of trash collected. As you can see, then it evaluates the environment state change each time we collect some trash. This is the method where it evaluates which state the environment should currently be in. So if we've collected one or more piece of trash, then it changes from heavily polluted to polluted, then 2, slightly polluted, then 3, clean. Of course, in the real game, it would require more trash collected to change the state, but this is just for quick testing. And then it calls the on environment state changed, which is the event action. And this is where the observer pattern comes in. So to explain this, I'll use the animal return script. That's the script that spawned the animals you saw before. I have here very basic, just a array of animals and then an array of spawn points where they can spawn. Both this script, animal return, and this script, which I'll explain in depth later, plant healing, subscribes to the on environment state changed. That way, when the environment improves, they automatically react. For instance, in animal return, I have this environment progress. That's the instance, the singleton we access here. It first checks if it exists. If it does exist, then it accesses the on environment state changed action event. And then this means that this is the method that reacts to an environmental state change. I set this in on enable to make sure that if the script I want to listen to the events is actually active. So I subscribe to it in on enable. I unsubscribe from it in on disable. And to do this, you just access the instance, the action event, and then plus equals to subscribe or minus equals to unsubscribe. Then what handle environment state change does is just for my sake, it logs an update, and then in a for loop I spawn a random animal. And what this method does, it just looks for a random animal in the array and then a random spawn point, and it spawns the animal at that position. So if we move on to plant healing, again on enable, I subscribe to the environment state change using the method grow plants. Unsubscribe from it and undisable. And what grow plants does, it just again logs to me. Then it checks if there's any more plants to grow. This is using a list of game objects called plants to grow. And if this is more than 0, then it in the amount of plants to grow per state, this is how many plants should grow per state change. I've set this to 2. Then it finds a random plant from the list to grow, and then it removes it from the list again to make sure that we don't try to grow the same plant twice. Then it sets the game object to active. At the start of the game it's inactive to make it invisible for the player. And then we start the coroutine. Now let's talk a bit about coroutine. I use the coroutines here in the growth coroutine for the plant healing. It makes it grow smoothly over time. So that's what coroutines basically does. It's when you want to do something over a time period instead of just doing it instantly. Instead of just having the trees like pop and then just appear out of nowhere, I make it scale over a certain amount of time. So we use the start scale, which is 0.1f, and the target scale, which is 1.0f. So this being 10% of the regular size, this just being the regular size of the prefabs I use. And then I use this, I found this pretty interesting as well, the play clip at point. This makes sure that the growing sound that I use to give audio feedback to the player that the plant is growing is playing at spatial 3D audio at the position of the plant which is growing. And then as long as the time passed, the elapsed time is less than the grow duration, so the amount of time it should take the plant to grow from 0.1 to 1.f in scale, I've set this to 10 seconds. The plant grows and grows and grows until the time has passed. I use the yield return null to wait for the next frame, and then it just makes sure to set the local scale of the prefab to the final scale, so 1f. Yeah, so that was actually all I wanted to show you. I hope this made sense. If it did not, then you can always comment down below. I'll try to either answer your comment, or if it requires a larger answer than just a reply to a comment, then I can always make a video about that, trying to answer your question. For instance, going more in depth with either enums or design patterns or coroutines. I hope this video helped you out, and I wish you all a good day.